All right, today we're going to build on what we did yesterday, working with slope-intercept equations. Today we're going to write slope-intercept equations given two different scenarios. First, we're going to look at writing equations when we have the slope given to us and we know one point that the line crosses. So using that one point and slope, we should be able to figure out the y-intercept so that we can write the equation. The second scenario we're going to look at is when we have just 2 points. Using 2 points, we can find the slope. Using the slope, we can find the y-intercept. And once we have the slope and the y-intercept, we can write that equation. So, by the way, this looks a lot like one lesson in particular that we did back in pre-algebra. So I know you have seen this before. This should be a refresher. But of course, now that we're in algebra, things will get a little more challenging with some of the numbers maybe that we'll work with. So writing an equation in slope-intercept form for the line that passes through point 21 with a slope of 3. What is slope-intercept form of an equation?
Y equals mx plus b.
Thank you. Y equals mx plus b. So the two things that I need to have to write a slope-intercept equation are m and b. All right, what is given to me in this problem? Slope. So I know that m equals 3. I just need to figure out what b equals. All right. Now, using this equation, y equals mx plus b, I need to start making substitutions in different places in the equation so that I can solve for the one thing that's missing. What's missing is b. So what can I substitute in to this equation? Okay, I've got an x and a y value right here, don't I? Okay, I know that the line goes through this point, so that means the two coordinates for this point have to be a solution to the equation. So I can use these 2 points in the equation. So y is 1. And 1 equals 3. 3 is m. X is 2 plus b. And once I've solved for b, I can write the slope-intercept equation. So 1 equals 6 plus b. Oops, got ahead of myself there. 6 plus b. Subtract 6. Negative 5 equals b. And so I know that b is negative 5. Now I can write my slope-intercept equation. It is y equals 3x minus 5. That's not too bad, is it? All right, I'm going to give you about a 30-second head start on the next slide to work through using the same method we just used and see if you can come up with the same slope-intercept equation I do when I work. Do we have something different? Did some of y'all put the 1 there? Okay, try not to put the 1 there. I probably would count it correctly because it is a negative 1 slope, but the 1 is unnecessary, which means we don't need it, so it's not in simplest form if the 1 is there. Okay? All right. Next, so that's objective 1 of the lesson right there. We're good to go on that one. If given the slope and a point, you guys can write the equation. So we're halfway there. Now, write an equation for the line that passes through the points 3, 1 and 2, 4. So we still need the same thing. We still need an equation in slope-intercept form, y equals mx plus b. I still need to figure out what the slope and the y-intercept are, but now I have a different set of information. Step 1 is find the slope. Can I do that?
Yeah.
Okay, somebody's saying the formula over there. Slope is y2 minus y1 over x2 minus x1. We have 2 points, so we've got those values. So the slope is 4 minus 1 over 2 minus 3, which is negative, or 3 over, it's negative 3 over 1. The value is negative 3 over 1, which is a negative 3 slope. So that's my m. Next, now we're at the same place we were on the last slide, right?
Yeah.
We have a point, we have the slope, and it doesn't matter which one of these two you use for your x and y value. They're both going to give you the same answer as long as you do the math correctly. So I'll just use this first one. Y is 1 equals negative 3 is m times 3 is x plus b. 1 equals negative 9 plus b. Oops, good grief. I keep jumping straight to the answer. Add 9 to both sides. 10 is b. Everybody agree?
Yeah.
Okay, so once we've got the slope and the y-intercept, all we need to do is write the equation y equals negative 3x plus 10. Why is that?
Because like slope and then they remove the y from intercept for its slope intercept.
You've got the slope and the y-intercept right in the equation. Slope-intercept form. Very good. All right. I love it when those connections get made. All right. Just a couple more examples working through this same type of scenario. We've got 2 points. Let's find the slope first. So slope is negative 6 plus 2 over negative 5 plus 4. Slope is negative 4 over negative 1, so it is positive 4. That's the slope. Now it doesn't matter which point we use, so negative 2 is y equals 4 times negative 4 plus b. Negative 2 equals negative 16 plus b. Add 16. 14 equals b. So our intercept equation, slope-intercept equation is y equals 4x plus 14. All right, we've got one more like this to work through. I'll give you a head start on this one. See if we come up with the same answer. leave it as improper fractions. -7 minus 5 second. 2. So y equals 2 thirds times x plus b. All right. Everybody agree with me?
Oh, I know.
You find your mistake if you missed it?
I did 0 minus 8 instead of 0 plus 8.
Oh, 0 minus 8 instead of 0 plus 8. Yep. I caught that mistake. I did, as I was writing it out, I did -7 plus 5. But I caught it before I did so I was able to make my correction. Yeah.
7 plus 5, 13.
7 plus 5 is 13. You
That was a weird
you
fraction.
struggle with those. All right.
That was a really weird fraction.
You missed the easy stuff. All right.
Whoa, wait. What?
Y equals -2 thirds x minus 14 thirds. Okay. All right. This last slide, we have a word problem to work through, obviously, and there's a couple of new vocabulary terms. I didn't give you a vocabulary slide, but I'm going to use the terms and give you the definition. First, let's read through the problem. The table shows the number of domestic flights in the U.S. from 2004 to 2008. Write an equation that could be used to predict the number of flights if it continues to decrease at the same rate. And then, after we've done that, then we'll estimate the number of domestic flights in 2020. So the first new vocabulary term is the word constraint. Does anybody know that word, constraint? Harley?
It's like a boundary.
It's like a boundary, exactly.
Don't go past where you die.
Yeah, okay, a constraint is a boundary. And in math, sometimes we have constraints. And in this problem, we have a constraint given to us in the problem. It says find, it gives us the constraint of the years 2004 to 2008. This table only goes to those years, but when we write the equation, those are the years that we have to use. It defines it defines for us the numbers that we have to work with. If we use other numbers, we might come up with a little different equation, or if we had a table that maybe had more data on it, we'd have to exclude some of that data because we've been given a constraint. We have to work with 2004 to 2008. So make sure that when you read the problem, you look for any constraints. You look for things that limit or set boundaries for what you're supposed to do. Aiden.
This is linear.
That's what the constraint is going to do for us. If you use the years 2004 to 2005 and set up an equation, and I use the years 2004 to 2008 to set up an equation, we're going to get different equations. And so the constraint gives us, it levels the playing field for all of us. We all have the same numbers to work with. Okay, so you don't come up with one equation that makes your proposal for the company look better than my proposal because you use different data. So we're using the same numbers as to level the playing field. That's exactly what the constraint does for us. Okay. So using these numbers then, because that's what we're constrained to do, we're going to write an equation. So we have two ordered pairs, and we need to write a slope-intercept equation. It's the same thing we just went through on the last 3 slides. We need to find the slope first. So when we're setting up an equation where we know need to use ordered pairs to find the slope, where does the time go on those equations? Time goes on the bottom in the formula. So we always want to set the time on bottom. I want to do 2008 minus 2004. On bottom, and that means that I need to do 9.37 minus 9.97.
I got a really weird fraction.
And what is that?
I got 0.6
Negative
over.
0.6.
Negative 0.6 over 4. Okay, and last chapter, I said if we get these weird fractions for a slope, what do we do with them?
Leave them. No. No, we
We
make it
simplify
properly.
because it's by year.
We simplify it. So divide it. What is it? 0.6 divided by 4.
It's 2.5.
It's
1.5.
negative 0.15. So that is our slope. Okay? Now, using either one of those 2 ordered pairs, we've got a slope that we can work with to find the y-intercept so that we can write our equation. So the y value is, let's just use this one, y value is 9.97 equals the slope, which is negative 0.15 times yeah, it's actually the way that the graph is set up, or the way the equation is set up, we're actually just going to use the number 8 because we're talking about years since 2000. What's 2008 minus 2004? Is 4. What's 8 minus 4? It's 4. So we're gonna work out to the same thing. It's just gonna adjust our numbers a little bit different so that they're gonna be easier to work with using this. Okay, so 0.14 plus b. Okay, so plus b. All right, so 9.97 equals negative 1.2
Yeah.
plus b. All right, so add 1.2, 9.97 plus 1.2 is going to be 10.07.
11.07.
10.07?
It's 11 because 2.
11.07. Okay, 11.07 equals b. No, I don't
It would
think
be 11.
it's not.
17. Yeah. Be 11.17.
Thank you. It's not.
17. 11.17.
No.
Yeah.
Yeah.
Still 1.
9.97 plus, yeah, 11.97.
Okay, we made a mistake all the way back here.
Yeah, should that have been 4?
That should have been a 4.
That's what I was wondering. Mr. Fisher's
Hey, I make mistakes. I'm okay with making mistakes. You guys are not okay with making mistakes is the problem. Mistakes happen. You gotta work around them. It's not a big deal to make a mistake. All right, so 9.97 goes here, and I used a y value from this one. I used the x value from that one. So why didn't you stop me way back there?
We tried.
Who did? Nobody said a word to me. Well, speak up next time. 9.97 equals negative 0.6 plus b. Thank you. Now add 0.6. That's the number I was looking for. 10.57 equals b. Okay, so now I can write the slope-intercept equation. The slope-intercept equation is y equals negative 0.15x plus 10.57. Okay, now the last part is this. Estimate the number of domestic flights in 2020.
So we put that in for X.
We put 20, since we're talking about years since 2000, we're going to put 20 in for x. So y equals negative 0.15 times 20 plus 10.57. Is that negative 3? Negative 3 plus 10.57, is that what it is?
Yeah.
Negative, huh?
7.57.
0.15 times 20 would be negative 3. And then plus 10.57. So y equals 7.57.
Yeah.
So that looks like 2. So our, now why do we call this an estimate if we put it into an equation and solve
It's
for it?
not linear.
Because
You don't
not
know
actually
for
right.
sure.
Well,
We got the-
no, it's linear because we created a linear equation. This is a linear equation
Goes to real life.
Because we don't know what's gonna happen.
because we can't necessarily predict the future. And that brings us to our first vocabulary term was what word?
Constraint.
Constraint, because we had a constraint on the problem. The last one is linear extrapolation.
Whoa, that's a big word.
Okay? Here's the deal. All that our equation does mathematically is prove to us what happened from 04 to 08. We can look at the numbers and we can show this definitely happened without a doubt.
We can estimate.
But all it does for the future is give us a line that we can kind of guess our number's going to be somewhere around this line. We can't know for sure if it's going to be exactly on that line because, stuff happens. Things like terrorist attacks and price fairs and fuel prices, all those things affect whether or not people are traveling. So, linear extrapolation, if they ask you for a linear extrapolation, all that means is they're going to use the equation you've written to try to make a prediction about the future. Okay? All right, here's your assignment.